Hi everyone, welcome. Today we're looking at percent of change from section 2.7, and we have two learning targets we want to learn about today. The first one is I can solve for the percent of change. And sorry about that, with the conveniences of this modern technology, I had that right in the middle of it, but we'll keep going. We'll press forward. Secondly, the learning target is I can solve problems involving the percent of change. So in the second one, we're not going to be looking at an exact question where they say what's the percent of change, but we'll be looking at items where there is some change in the price, some other factor. We're looking at things there more like sales tax questions and discounted price questions, things like that. Okay, so let's look at some formulas we can use. So first, when we're looking at percent of change, and we'll get back to this in a second, but we're looking at new minus original divided by original. That's how we can find the percent of change using the formula. So we take the new price or the new amount, whatever we're talking about, and we subtract the original value from it, and then divide that answer by the original value, and that will give us the percent of change. So like I said, we'll come back to that in just a second. Now, in this next one, here's an example of a discount problem. There are two ways to solve it. Well, there are a lot of ways to solve it, but I'll go over two with you here. So first case one, we can say, okay, it's a $95 glove. So we had a $95 baseball glove. It's at a 15% discount. We can take this $95 times 0.15, which is just 15%, expressed as a decimal. Remember, with a percentage, to express it as a decimal, you'll divide by 100 or move the decimal over two places. So now we have 0.15. Then we would just multiply that out and get an answer. So we'd have 95 times 0.15 would give us 14. $25. So that would be $14.25 would be the amount that we would take off, the amount of the discount. So then what our true answer would be, we would take the 95 and we would subtract the 14.25. So at $95 minus $14.25. And then we would end up then in that case with $80.25. So we'd end up at 80.25. Okay, so that's one way to do that type of discount related problem, is take the percentage up front, multiply it by the cost of the item, get a value, and then that's the amount of the discount. So we subtract that amount from our original value of 95 in this case, and we end up with $80.25. Another way you can do those is take the discounted amount into effect right up front. So if it's a $95 glove and we get a 15% discount, ask yourself what percentage of the glove are we still paying for then? We know that $95 is 100% of the cost of the glove. If we're taking a 15% discount, we can go right up front and say, okay, we're only paying for 85% of the glove. So we can make that as a decimal of 0.85 because that's the amount we're paying for. So now we could do this one in one step. This way we could say $95 times 0.85. And we can see what that's going to equal. And I think you already know what it's going to equal, but 95 times 0.85 equals $80.75. So now let's look at this. They should be exactly the same, but yet they're not. And I can see what happened here. When I subtracted 95 minus 14.25, I wrote down $80.25. What that should be is $80 And hopefully you guys would have corrected me on that quickly. I'm sure in class you would have, and maybe some of you would have told me about the video as well. Hopefully you would. But anyway, here we are then. So now they equal exactly the same thing. So you can take the discount on the front end or on the back end, and it really won't matter. Now, same thing with sales tax. You can do that in one step or two, and I'll leave this one up to you. But basically, you can either take $35.99 times 0.0675, get an answer, and then add it together to the $35.99, or you can take $35.99 times 1.0675, and when you multiply that by that 1, that brings this $35.99 into your answer. And then the 0.0675 will add on the tax part, and so you in one step can get the entire answer as well. So either way is fine to do it. Just depends what your preference is. Both will get you the same answer. I would like all of you to make sure you write down the second one here and go ahead and solve for that. Okay, now let's look at a couple more examples of how these work with percent change specifically. So here you got three different things. We took some items from 1975 and had some prices, and then compared them, those same items, with 2014 with some prices. So the prices have obviously changed. Some things have gone up, other things have come down. We typically think of prices going up over time, and they generally do, but when you take technology into account and things, sometimes you can get items for much less now than you could back then as well. Okay, so let's look at how we would actually solve these. So remember, we want to use new minus original over original. So in the first case, new would be 21,000. We're looking at the car now. Original 5,500, and divide by 5,500. That's how we'd set it up. And with the running shoes, we'd have $89.99 is new. 1475 was the original. We divide by the original of 1475. And then with the camera, here it was $75, the new price. The old price was much more expensive, and then we divide by the old price or the original price as well. So then just working all of these through, we can get answers for these, and I want you to take time to go through these calculations as well. But when we solve all these, in the first case, we would end up with 2.82, and again we want to express it in a percent of change. So we want to change this decimal to a percent, so we'd multiply by 100 or move it 2 places over to the right. So this would be a 282% increase for the car. In the second one, when we're looking at the running shoes, that's actually a 510% increase. And now when we're looking at the camera, that's actually a 75% decrease. So looking at, again, the formula, new minus original over original, you can take, you know, the information we have here for the car, for example, plug it in, work through, divide it out. You get a decimal originally, and then you want to turn it into a percent. Just move the decimal over 2 places to the right, or multiply by 100. That's how we turn a decimal into a percent and get your answer. And so again, that's the percent of change, and this is the type of problem that that's real handy to know about in real life. You can use this one quite often to compare values of things, or if you want to compare the cost of one car versus another, or one shirt versus another, one pair of shoes versus another. You can use this kind of analysis to do that. So hopefully this will be helpful, and I will look forward to seeing you in class soon. Sorry this one went a little longer than some of the others, but I did want to show you some examples so that you were comfortable in dealing with these types of questions. I'll look forward to any more questions you have for me, and thanks very much again. Take care. Have a very, very good day.